Breaking news, a new discovery in science today.
Better HD music quality you can receive at your home using a simple op amp.
I'm Tyson.
I'm Ross, and here's the story. In order to get easy HD quality music, you need to set up your op amp in the circuit as shown. The next video will show you how we set it up. Here's our inverting amplifier circuit. We've got 15 volts going into the VCC. We've got negative 15 volts going into the VEE, as you can see here. We have our circuit hooked up to the oscilloscope, and as you can see, here's our input in, and it's got like a 0.5 magnitude, and here's our input out, and it's got a 5 magnitude. So there's it's 10 times as big for the input out, so that's 10 gain. The gain is 10. So that's because this resistor is 10 times bigger than this resistor. And also, the phase shift is 180, because as you can see, this one is inverted down. This one goes down as this one goes up, and the opposite. So the phase shift it shifts over completely once, so that's 180 degrees. Alright, we've got our music hooked up to our op amp. And you can see our input in is a small line, and our input out is big gain. As you can see, all this stuff, which proves that we have gain coming out of our op amp from the music. And yeah, you can see the sine graphs. If you remove that resistor as shown, you will get a unlimited source of voltage going into the speaker, which creates a disturbance in the signal given and gives the sound quality a high scratchy pitch type sound. And there you have an easy way to create HD music through an op amp. Now I'm going to go to Tyson to show you how the schematic works on LT Spice.
So this is our inverting op amp circuit in LT Spice, and where the non-inverting input is with the plus sign and the inverting input is at the negative sign on the op amp. The two golden rules of op amps is that there should be no current going into the inputs and that the voltages at both inputs should be the same. And because there should be no current going into the inputs, that means that the current over R1 and R2 should be the same, which is shown in our chart. So then we measured the currents. The green line is the current coming out of our power source. The blue line is our voltage after the first resistor, and then the red line is the voltage after our second resistor. The second voltage drop is much bigger than the first, which makes sense because they have the same current running through them, but the second resistor is 10 times bigger.